Let's take a look at the workflow of the Dragon Ribbon simulation. First, we build the bone-driven system. Once this step is done, there will be far fewer clipping issues in cloth simulation. It's best to do this in the character's T-pose. Select all controllers. Create system. Add a large waist ring. Add leg bones. Select the skirt controllers. Add them in. This step needs careful attention. Make sure all skirt controllers are selected. There's nothing particularly complex here. I've just sped up the video. Enter initial pose. Bone system. After setup is complete, you can export the parameters for reuse next time. Next, we add the ribbons. Add all ribbons that need simulation into a group. Make sure every controller is included. Add them one by one into the group. You cannot put multiple ribbons into the same group. Again, nothing special here. It just requires a bit of patience. I'll speed it up again. It's worth noting, if there are too many bones, for example M character rigs, you can select them in intervals. I'll demonstrate this later with a walking animation. Selecting every few bones like this also works. There aren't too many controllers here, so we select all of them, and check the result. Controllers around the skirt are added into the group one by one. Data can still be exported. I will save a separate file for animation export. Let's pick a walking animation. We'll use this happy walk animation. You can see there are still many intersections. At this stage, just use bone-driven simulation. Now there are almost no intersections. This adjusts the timeline range. Set it to match the animation timeline. If we run cloth simulation directly here, intersections will reappear. Let's adjust the parameters again. First select the bones. Add collision capsules. Increase softness, and test the result. You can see, no more clipping on the thighs, but still on the calves, so we add collision capsules for the calves too. Let's add calf collision as well, and test again. The simulation seems slightly off, because some parameters are not tuned yet. Let's Ctrl+C, undo the simulation. The intersections may be caused by too much inertia, so we reduce inertia, turn off softness randomness, and lower softness. Too much softness makes it hard to follow motion. I also added gravity to make the skirt drop faster, but the recording didn't capture it. Here at the red circle, gravity was set to 2. Uncheck Keep Pose. If enabled, the skirt will return to its initial pose after simulation. For looping animations, you can enable it. For animations with movement, it's better to simulate a few dozen frames ahead. With these settings, the result looks pretty good. Next we'll talk about fast-running animations. Let's import a running animation. Match simulation timeline to animation. Still start with bone-driven mode to reduce clipping. Still some intersections appear. No problem, we can tune parameters to fix it. Adjust this value To increase bone-driven amplitude, 3 seems to high. Set it to 2. Depends on actual animation. You can also adjust hip influence on the skirt. Still add collision capsules, then run simulation. Let's test previous settings. Simulation looks good, but still some clipping, because the run is too fast. Collision detection is not sensitive enough. Increase simulation step size, so collisions are detected faster. After increasing step size, collision becomes more responsive. If still not enough, increase sampling density. Now let's handle attack animation. Same workflow as before, bone-driven mode again. This animation involves rotation, so we add centrifugal force. Select root controller. Click Add. Result looks like this, with centrifugal force, but there are still some clipping issues. Let's adjust parameters. Try tuning centrifugal force, but it doesn't seem related. We use a previous method. When bones are too many, select them in intervals, and simulate again. Let's reselect skirt bones and run simulation. There is a softness random option. We can enable it and keyframe it. Select all skirt controllers. Click Softness Keyable. Create a keyable attribute. For skirt softness, we want low softness at high speed and higher softness when slowing down. Now softness is keyframed from low to high. Let's simulate. Tail or hair simulation also requires collision setup to avoid intersections. We add collision to cover the whole skirt. Enable self-collision system. Many parameters available here. Simulate selected group first. Almost no intersections now. Delete animation. To remove ribbon animation, increase speed parameter. To test result. Swing becomes faster. Reduce amplitude to make smaller motion. Increase frequency. Higher density waves. More snake-like motion. Angle can be adjusted to 30 degrees equals vertical swing, 90 degrees equals horizontal swing. If not obvious enough, increase amplitude and speed. Reset parameters. Let's talk about softness keyframing. Select root controller. Set softness keyframes. Different times equals different softness values. Create smooth transition. Dynamic rhythm in tail motion. Hair simulation is similar. First add collision. Keep hair away from back. Avoid clipping. Initial pose should not intersect. Simulate directly. still some hair to accessory clipping. Try tuning parameters, or simulate separately. Increase softness for accessories. Slower fall speed. Reduce gravity to 0. Longer floating time. Reduce softness again. Clipping is mostly reduced. Minor clipping remains. Fix it with animation layers. Hair workflow is similar. Add collision first. Keep hair away from back. Avoid intersections. Adjust initial position slightly, then simulate. Still some hair accessory clipping. Try parameter tuning or split simulation. Increase accessory softness. Adjust gravity to 0. Then fine-tune softness. Reduce remaining intersections. Minor issues remain. Fix with animation layers. For final polish. Run hair simulation for running animation. Same general workflow, with small adjustments. Increase frequency and speed. Faster hair motion. Attack animation simulation. Same workflow as before. If less manual keyframing is needed, add more collision objects. At head and arms. That's all for this tutorial. If you like it, we can make more case-based tutorials.